Great. Hello, everyone. Welcome to our Filecoin Core Devs call number 51. Today, I'm hoping that we have more people join us. If not, that's fine. We just have two main discussion points today. We're covering the interplanetary consensus, formerly HC. I think that's the hierarchical classification of consensus, I don't remember. And it's going to be led by Alfonso, as well as a FIP discussion on improving AC security with consistent broadcast. Again, FIP, Alfonso will be, he has volunteered to lead that conversation as well. And then we can take questions and answer afterwards. I'm not sure if he is, yeah. Great. So I will hand over now to Alfonso to take it.
Thank you. So I guess, I mean, you're going to share the slides, or should I share my screen?
I have them here, but I can let you. Yeah.
Let's do it.
Just let me know how to move around.
Perfect. Cool. Okay, so I mean, today what I want to present is the Interplanetary Consensus, or Hierarchical Consensus, which is a project that it was a research project for the past year at Consensus Lab, and now we're starting to feel comfortable to deploy it over the Filecoin network, and we wanted to start socializing the design and like sharing with everyone what we're trying to build, and like get as much feedback from all of you and like start discussing what are the key points of the design. So I guess like many of you may be already convinced that one of the key bottlenecks that we have right now in blockchains is the consensus layer. I mean, if we go to Bitcoin or Ethereum, we see that these consensus layers is in the order of the dozen of transactions per second. And that's why we see like proposals like the Lightning Network and Layer 2 platforms in order to improve this scalability. But even if we go to the ordering of transactions and like the best consensus protocol at I mean, any BFT or any specific consensus protocol, if we don't have a way of horizontally scaling these protocols, we are limited by the single validator and the specification of the single validator that is proposing the blocks. Next slide, please. And with hierarchical consensus, what we are proposing is a way of like trying to achieve like these targets, because if we want to start accommodating Web2 loads, as Juan has been saying through Lab Week, into Web3 infrastructure, we really need a way of horizontally scaling the consensus layer and horizontally scaling blockchains in order to achieve this kind of properties. And the ones that we are really targeting with HC is the first 1, 2, 3, 4, 5, 6, 7 ones, where like we want to have high throughput, fast local finality, so be able to run a consensus in a data center and still be able to communicate with the rest of the network, make it as flexible as possible for everyone to be able to handle, because like not every application will have the same requirements in terms of performance and security. So we want developers to be able to configure the underlying protocol to whatever they need. And also one that I really like, which is of course horizontal scaling and partition tolerance, because up till now it's not easy to, I mean, the current proposals for scalability, they don't tolerate partitioning. With our protocol, what we are hoping is to have like this local consensus and be able to support potential partitioning between like of some parts of or some of these subnets of the system, and still be able to propagate all of the changes eventually when the connection is recovered. Next slide. Okay, yeah, so these are the requirements, cool. And you can like click once again so that we have the whole, yeah. So with hierarchical consensus, in the end, what we want is that, as we think that there's no one size fits all consensus for every use case, what we want is to try and give a framework that allows applications to fine tune the consensus layer to whatever their use case needs. So we will be able to accommodate the kind of more DeFi, like fully Web3 application, or more Web 2.0 or computation applications where we may not need that level of security, but we'll still need verifiable computation and SMR properties. And that's the idea behind this hierarchical consensus, to have an on-demand horizontal scalability for Filecoin. And we can think of this proposal as an alternative to sharding and sidechain. So it's a mix between both of them. And what we want to give is full configurability to all users and to applications to be able to fine-tune the underlying consensus and the underlying blockchain infrastructure to whatever their use case needs. Next slide. Yeah, so yeah, thank you. I mean, in the end, like what we do with hierarchical consensus is that we have a rootnet. We can think of the Filecoin mainnet, and this is the high-level architecture of the protocol, or what we're hoping to build. And we have the Filecoin mainnet, for instance, as the rootnet. And here we have like 30-second blocks and a finality that it's way longer. So it may not be perfect for certain use cases, and especially like after FVM, where we have programmability, some use cases may not be, these block times and this finality may not suit all of the use case. So the idea with hierarchical consensus is have a way of deploying different subnets. So let's imagine that a set of users, or developers, they want to deploy their own use case, and they need like higher performance and higher throughput. So what they will be able to do with hierarchical consensus is deploy a new subnet, and this new subnet in the end is just an independent network with its own state, its own consensus algorithm, its own mempool. So all of the stack from scratch is independent, and the idea is that it will be validating transactions in parallel with the ability to still be able to interoperate by design with all of the other subnets of the hierarchy. And this will build, so the same way that from rootnet we were able to deploy new subnets to accommodate new use cases with a new consensus algorithm and so on, and validating transactions in parallel, we would be able to, this property is recursive, so from a subnet we are also able to deploy new subnets, and in this way the developers of the use cases are the ones that start building and growing the tree as they need it. Next slide. Yeah, so now let's look at how this is implemented at a low level in terms of the logic. So we see that here what we had is like the rootnet, and then we were deploying subnets. So the two key core like components that orchestrate all of the logic are two user-defined actors in each subnet that handle all of the logic for these sections. So what we are hoping to do is in the Filecoin mainnet to deploy a user-defined actor that is the IPC gateway. And this gateway in the end is the one that will handle all of the logic for HC in the rootnet. Every subnet, so if you can go click a few times in the keyboard so that everything appears, thanks. You see that every subnet, they have their own IPC gateway, and this IPC gateway is the user-defined actor that enforces all of the logic for IPC. So it will handle like the collateral that users need to put in order to deploy a subnet. They will handle all of the orchestration of the cross-net messages, and something that's because subnets are able to validate transactions in parallel, they're able to interoperate with other subnets in the system, and they also can anchor their security to the security of their parent by leaving like proofs of the state of the subnet, by leaving checkpoints in their parent. So periodically sending checkpoints to the parent. If someone wants to deploy a new subnet, how it works is that so the subnet actor is the user-defined actor that implements all of the governing policies for the subnet. We have a reference implementation for this, but anyone could come up with their own, as long as we implement the interface, anyone could come up with their own governing policies for the subnet. And if we want to deploy a new subnet, we first deploy this subnet actor, and from there on, we can start like, we can deploy one of these subnets and start mining. But we won't be able to, so in order for this subnet to be able to anchor the security, so create checkpoints and send crossnet messages, it will require to register to the IPC gateway and put some collateral so that we have some insurance in case, because we don't assume and we don't guarantee any security in the subnet. So in order to prevent potential attacks and misbehaviors, like report potential misbehaviors in subnets, we enforce a collateral for users in order to register the subnet. Next slide. Okay, so we see how was the architecture, how it is implemented low level, and in order to like the way in which we implement this at a client level. So right now we have an IPC node. In the end is a client, like the client for IPC is based in Lotus. And the way in which we implement the synchronization with new subnets is just by replicating, like spawning full stack for a new blockchain. So so let's go step by step. So here in the IPC node, we see the representation of two subnets and the stack for the two subnets, and we see that we share the transport layer. So in the transport layer, we just have gossip sub, and we have different topics for the different subnets. And this is the way in which we interact with the different subnets and share messages with the different subnets. And from there on, like all of each subnet, they have their own message pool, their own consensus. So here we have, for instance, Mir and proof of work in the right, their own state tree, their own FVM, and their own API, and they're validating and creating blocks in parallel. And then we have this special like message pool that is the cross message pool, which is a message pool that is syncing with the parent, with their parents. So here we can see that the parent, in this case, like we would, in the Filecoin case, we are syncing to the Filecoin mainnet or to whatever other parent. So eventually this could be Ethereum. The framework is general enough to support any kind of network. And this cross message pool, in the end, what it's doing is not only, so the traditional message pool is listening for unverified messages that need to be proposed in the network. And this cross message pool, what it does is listening to the parent in case there are pending messages that needs to be from other subnets that needs to be proposed in the current subnet. Next slide. Yeah, I'm not going to go in depth into the checkpoint protocol. In the end, we can think of the checkpoint protocol as a way to propagate information to the upper layers of the hierarchy, and also to anchor pieces of the state of the subnet into our parent, so that eventually, like with this, as we are sending checkpoints with some information about the subnet, we can build fraud proofs, and we can build other kind of mechanisms to report misbehaviors. And the way in which we propagate crossnet messages is, so we have two ways. As you saw in the architecture for the node, if we can click a few times so that all of the animations go in. Okay, so if as we saw in the architecture for the node, we are always listening to events in our parent to see if they're pending messages, or if there are new events or something happening in the IPC gateway or in the subnet actor. So propagating messages top down is quite easy, because like we have this assumption that the child subnets, they need to necessarily sync with the parent. And then so the ways in which we propagate crossnet messages between the two between like the whole system, and how we propagate this information between subnets is using top-down messages and bottom-up messages that we call. The top-down messages are quite straightforward, because as we're syncing with the parent, we can see that there are unverified messages that need to be proposed in the subnet. But for bottom-up messages, we use checkpoints, because parent chains or upper layer chains, they're not syncing with their children, because if not, we would have state explosion. So we leverage the checkpoints as a way of packaging potential messages that needs to be propagated up, and that's the way we use to propagate up the messages. Next slide. And I mean, this is just to show you how a cross message would be proposed in a subnet and propagated to a subnet. So if we send a cross message from the for instance, in the Filecoin mainnet that we wanted to go to one of the subnets, we would send a message to the IPC gateway in the parent, and the IPC, so the children are listening to events in the IPC gateway, they will see that there's an unverified crossnet message that needs to be propagated further. So the parent bridge will, the cross message pulled through the parent bridge will detect that there's a new message, and it would be proposed as any other message in the network. So crossnet messages in the end in the subnet are proposed as if they were any other message in the current network, but the validation that it suffers, like it has additional validations by checking the state in the parent. So if you click a few times, a few arrows should appear, like explaining the whole place. Okay, and so when we were figuring out how to do this horizontal scaling and these like MongoDB went a bit into the text, but like how we were figuring out how we could do these. Yeah, next, you can go to the next slide.
Okay, sorry if I'm
sorry
too fast. Hold on. Here you go. Yeah,
so a few things that we were exploring and where we got inspiration for these IPC. I mean, the two ways we could like approach scaling for blockchain was either using vertical scaling, where we try to come up with a better consensus algorithm. We've seen several attempts of that not working. If we really want to scale a lot, we should use horizontal scaling. And then for horizontal scaling, we explored sharding, payment channels, side chains, rollups, and like everything that people are doing. And in the end, we came with this approach, which is a mix between side chains and maybe sharding, but we are not explicitly partitioning the network. So instead of forcing, like, for instance, the Ethereum approach is that there are clear shards and there's a clear protocol on how to partition the network, or at least that was the case, because now they're going into more a layer 2 rollup approach. But what we wanted is a way where users and developers are able to influence the infrastructure according to their needs. So instead of explicitly partitioning the network, what we want is that according to the demand, the infrastructure is adapted to the needs of the users. If you go to the next one, yeah, so you can keep going. In the end, like with IPC, hopefully we want to be able to support, because like we are trying to come up with a flexible framework and configurable framework thanks to the FEM capabilities. So that, and that's why we have the subnet actor, and we have like the which is user defined, and we have like the ability to implement different consensus, because in this way we could, like, for instance, decentralize sequencers in a rollup, because with the checkpoints we could use as checkpoints are also configurable, you could configure checkpoints as a rollup and then implement a consensus where your subnet is your validators in the subnet, they behave as the sequencers that are building the rollup to propagate in the checkpoint. So the idea is to have a general framework that would allow all of these things. There are a bunch of discussions on how hierarchical consensus is different from other layer 2 solutions. We may not have the right answer, but please jump in if you're interested and you want to give some input on this. We will love all of the feedback that you have. Next slide. And really briefly, like, what are the key models that makes, because actually we are not, so we can think of IPC as an application over the FVM and Filecoin, and we don't expect to change much in the underlying protocol. So we want to try and make this an application and write it as an FRC, so that we can have like different even implementation of subnet actors, of even IPC gateways, and have it on an FRC so that we have common interfaces, but allow the community to come up, like, for instance, we are dividing into different actors. Like we have the subnet actor, we have the IPC gateway as a different actor, and we have the atomic execution protocol, because we support atomic executions for actors as a different actor. And the idea is to have these actors as reference implementations, but like improve the protocol, like agree on common interfaces so that we create a whole community, and not like, this is not a change that requires hopefully a change in the protocol. And these are the main models that conform IPC. We see that we have the IPC gateway and the subnet actor that I mentioned. We have a consensus interface for anyone to be able to implement, and these we are trying to upstream it to Lotus, but have a consensus interface to be able to implement different consensus algorithms for our subnets so that we don't have to ascribe to a single one. We need a new type of addresses, and I guess this is something that we really want to start discussing, because we need a way of like uniquely identifying an address in a subnet. So we have a proposal of how subnet IDs work and how to build these hierarchical or IPC addresses. But and there are a bunch of discussions that I can link, but we will love to double check our assumptions and start discussing this, because I think this could have a lot of value for the Filecoin ecosystem. The same for the checkpoint protocol and the cross-net message execution. As I've said, like these are general protocols that are configurable, but it would be great if we can agree on or start discussing the interfaces for these checkpoints, the different fields that we want to add in these checkpoints, and so on. So we're hoping to start a discussion on each of these parts, especially in the ones that you're more interested, so that we can start getting clarity. And as we're moving to production, we get more feedback from the community. Next slide. Okay, and to give you a glimpse of what we have so far, we have an MVP implementation of IPC in Eutico. Eutico, in the end, it's a fork of Lotus that we use at Consensus Lab to do all of our testing and innovations. So usually what we do is that in Eutico, we just push the code and try a lot of things there. And then once they're ready and we see that they work at an MVP level, we try to move it into a more production ready to the Lotus base code. So right now we have an MVP, but we want to release, so by the end of this month, we should have the first release of the SpaceNet, which is a testnet where we're gonna test first the Mir protocol, so and FVM, so it's like the rootnet for an eventual IPC testnet. So this is what we have so far. There's a spec that needs to be updated, but as a baseline for everyone to at least know how the MVP worked. From the MVP to what we have now, a lot of things are changing. Actually, the first MVP used the legacy VM because FVM wasn't a thing. Now our actors are targeting FVM, and that's why we're moving from a lot of protocol changes and spec actors and all of this to actually going to user land and trying to make all of our actor user-defined. And also there's a FIP discussion and a paper that a high-level paper that gives a bit of an overview of more an academic overview of how we came to this protocol and how it works at a high level. Next slide. Yeah, and there are a bunch. So if you want to check the code for the actors, we have also in these links, we have the IPC subnet actor reference implementation. It's being changed a bit because we are trying to catch up with the changes in FVM. And also we have the IPC gateway, the uptime checker, which is because as part of the subnets, for many of the use cases that we think that hierarchical consensus and IPC can be useful, it would be also useful to know if the validators are online, not only participating in the consensus, but are online. And many of the applications, for instance, this came when we were thinking about using IPC for to handle the different geographical areas for Filecoin Saturn. So we need an uptime checker, and this is an actor that checks that in an area or a specific subnet, the validators and the participants of the consensus are actually online. So there you can see it needs documentation. We're trying to have all up and running for the SpaceNet launch, but the idea is to start deploying this in testnet and start the discussions so that we can build a proper FRC and we can get a bit of a sense of what the community wants with the protocol. Next slide. Yeah, and I think I mentioned this, like our focus right now is to try and upstream through, I mean, we're trying to build this testnet, and we want to upstream some of the changes that we are making into Lotus if it's possible. And we're going to start running this SpaceNet, this long running testnet from by the end of November. It won't have support for subnets, so there we will only be running a Filecoin testnet with FVM and a new consensus algorithm, so the mere consensus algorithm. And then, like, we are spending a lot of time now. So we went from the legacy VM to targeting the FVM as a built-in actor, and now we're trying to move everything to user-defined actors. So this is what we are focused right now, trying to move IPC from like more protocol land to user land, so that we can start deploying it and testing it over this network that has a new consensus, and that way testing all of the pieces while we discuss the low-level details of the implementation with the community. And I guess that's all from my side for IPC. I hope it's kind of clear, but like happy to keep discussing, or feel free to open any discussion that you may have to discuss it async. Thanks.
Thank you so much, Alfonso. I was trying to look for where my unmute button was. Do we have any question or any comments? I think we have some time for feedback, or before we go into our next and final session.
I have a couple of quick questions. Excuse me that I'm still a little sick from Lisbon. And sorry if I missed this also during your presentation, but to try and close the loops of some of the open questions you stated, you mentioned that there may be a new type of address class necessary to optimize usability here. And it looks like someone previously had flagged that the F4 address class proposal that's being worked on may be a solution. Have you followed up with that thread by chance?
Yeah, so I thought it would, I mean, initially I thought that and actually I have it in the presentation, that F4 addresses could be, bless you, could be useful, but then, and I would love, Alex, if you can follow up, because I think that you had some concerns and about F4 not being what we need. I haven't like gone in depth since our conversation, but like I thought F4 may be useful, but it's true that we need interoperability between several, not within the same subnet, but several subnets, which F4 may not give us that capability.
Yeah, just briefly, I think they're solving different problems, and they're both worthwhile problems to solve. I don't think F4 is going to solve the problem that you have, or the opportunity that you have to introduce addressing that can address a particular chain. F4 addresses, like every other blockchain address everywhere, are implicit about what chain they're supposed to be resolvable on. I think there's a great proposal in here for a universally resolvable blockchain address that could solve issues broader than Filecoin. So I'm excited about this part of the proposal. I think there is still work to be done here. It could be really good.
Gotcha. Thanks.
Great. Thanks, Alex. Thanks, Alfonso. Any other comments or question? No. Okay. We go back to you, Alfonso, for the EC security conversation.
Okay, for this one, I hope I do a good job, because I'm covering for Kai, which is even later in his time zone. So here we wanted to present a FIP that what we're trying to achieve with this FIP is to prevent a security vulnerability that we found in Filecoin EC, because we've realized that it's possible to perform an end split attack in the Filecoin consensus, and in the end split attack, in the end, what happens is that a malicious service provider can game the cutoff time in order to try and equivocate other service providers. So in the end, this malicious service provider, what it would do is when the cutoff time is approaching, it will send a block, different blocks for the same ticket to different service providers, and in this way splitting the network. So in the meantime, as it splits the network, the malicious SP itself will start like building its own local chain in order to have a heavier chain than whatever it has split. This is true that this is a low likelihood attack, but it could be really, I mean, it could really damage the network because it would affect the safety of the protocol. And there's a security analysis that Sarah and Guy have been doing that hopefully eventually we will share it and they're gonna publish it soon. So this is the current attack, and the proposal in the FIB is to use consistent broadcast. So we went through several options to prevent the attack. The first one is removing blocks from making tip sets, making tip sets to have a single block. But of course, this is not an obvious change, and it will require an upgrade to Filecoin. The second approach was to use asynchronous consistent broadcast, because like if we have consistent broadcast, what it would happen is that in the end, we can ensure that for the same ticket from the same miner, all of the service providers are receiving the same block. So with consistent broadcast, we have this feature. We thought about using an asynchronous consistent broadcast, but the problem is that rolling this out in the network will require, again, an upgrade. And then we came up with the idea of using a synchronous consistent broadcast, relying on the magic number of like 6 seconds. This is configurable, but we, like, as gossips up, one of the properties of gossips is that every 6 seconds, like in 6 seconds, a block has been broadcast to the whole network. So our proposal is to use a synchronous consistent broadcast where the service providers delay for 6 seconds the delivery of the block. And with delivery, I mentioned like actually accepting a block for a specific ticket. And in this way, like if a malicious service provider is trying to equivocate, as we don't have best effort broadcast as right now, but a consistent broadcast, eventually like we're delaying. And if we see more than one block, for the same miner on the same ticket, the service provider will reject both of them because it means that it's equivocating. So that's the idea behind this synchronous consistent broadcast. We would delay the delivery of a block for 6 seconds or whatever other number that we come up with. Like these 6 seconds is just because gossips up, but it's true that then service providers, they're playing with their cutoff times and so on. So it may require some tweaking. But by delaying this delivery, we can keep listening for new blocks for the same ticket, and eventually, as service provider will keep broadcasting the blocks that they've found, we would realize if someone is trying to equivocate or not. And in this way, removing the ability of like splitting the network by equivocating and like forcing blocks to different blocks for the same ticket for different service providers. We already tested, so we have we wrote this FIB discussion. I think Sarah and Guy are releasing the attack soon, so we would love to move fast this FIB to draft and like to the implementation if that's possible. And we have the implementation of this synchronous consistent broadcast in a branch of Lotus. We've tested it, and we also did some testing with the attack, but we would love to like have some support here because we tried to actually run the attack over testground to see if our fix actually worked, but we would love some support from more knowledgeable people in terms of Lotus and Filecoin to see if this is the case. But yeah, like we have the code for the synchronous consistent broadcast already, and we have like a potential code for an attacker of how this would work. And yeah, we would love feedback and like any support that we can have to test that this works and to start rolling this out to the service provider. That would be great.
Great, thank you. Do we have questions? Alfonso? Yeah.
Yeah, actually, I have some comments. Yeah, in that FIP thread. So okay, I have a few questions here. Yeah, the first one is that yeah, this approach. Yeah, I think it's good. That yeah, first thing is that this actually is not mandatory. Yeah, because you cannot detect. Yeah, you cannot confirm if a service provider take this or not take this, right? So the first thing is that I'm not sure if this should be a FIP or FRC. I think this could be discussed. Yeah, from the process point of view. Okay. Yeah, this is one thing, and another thing is that I had comments. Yeah, in that thread. Yeah, because I know. Yeah, I discussed actually with many storage providers, and actually different storage providers may have different cutoff time setting. So I'm not so sure if there will be majority of storage providers will take this approach or not, because this is not mandatory, right? So that is my concern. We have to make sure that majority of the service providers will take this, and this could actually take effect. So I'm not sure if we should to take a survey about this, or because we really need to know if people will prefer this or not, to make sure that this really work, right?
Yeah, so I hope I'm not making a mistake here. Again, I'm not the one like did all of the analysis. I just did the implementation, but I think that the increase, so the cutoff time is independent from this, right? So here, what we're saying right now, what you do is that you accept every block that comes before the cutoff time. Here, what we're saying is that, which means that eventually, if you see two blocks for the same ticket, you could, I mean, in that cutoff time, you could detect it without this. But here, what we are proposing for service providers is that they don't want to be vulnerable to this attack. So in the end, the fact that we're using this synchronous approach makes it, it improves our probability of being, of preventing the attack, but it doesn't, as you mentioned, like it doesn't completely prevent it. Because if not, if a majority of the network doesn't support this, it may be the case. But it's true that I think that it's independent from the cutoff time, because in the cutoff time, like if you increase the cutoff time, what you're doing is that you have more time. It's harder to game you and trying to force you to accept a block by the end of your cutoff time. I have to know your cutoff time in order to be able to force a block in you in the last moment.
Yeah, but the question is that, if we set the cutoff time later, I mean, wait for a longer time, and you may get heavier chain, right? So and you might win in the next round. So that's why people want to move that cutoff time, like.
Right, but my point is that if I want to do the attack to you, I need to know your cutoff time, because what I'm going to try to do is, like, before you broadcast to the rest of the network, I'm going to try to, for instance, send you a block before your cutoff time so that you accept that from me and like forget about whatever else comes from me. And then I will send, before Alex cutoff time, I'm going to send him the block, a completely different block, so that you accept different blocks for the same ticket. So I think that this is independent of the cutoff time.
Right, understand. But so I mean that actually the storage providers may not really care about this kind of this kind of an attack. They only want to get the heavier chain. They may not really care about this. And also there's the consensus fault report. We encourage them to present this. So this is why I have this concern.
I mean, I completely feel you. And just one point, like they will care. I mean, I think that they will care because the thing is that the longest chain, the private chain that the attacker will be building will be the heavier one. So it will push a fork that will make if they're splitting the network, I mean, and I'm building I'm equivocating the network so that they don't have all of the blocks, and I'm building the right chain. When I publish my chain, it will be the heaviest one, and it will deem useless the ones that you were building, because I split the network and you're pointing to the wrong. I mean, they cannot build a tipset because they don't have the same parents, because I split the network.
Okay.
Actually, it would be useful to have a picture here. Maybe I have something here. I guess. Yeah, I don't know if this is gonna help. Yeah, I don't know if I solved your concern. I mean, we have the same concern with service providers. We don't know what they will want. This is all of the reasoning that we've made, but we don't know to what extent. So maybe a survey is a good idea. I don't know.
Alfonso, I think if there's help needed to reconcile this challenge, we can also find ways to lend you support in doing that. Do you know when you expect to write the FIP draft for this?
So we can start whenever we start like aligning on the design. That's why we wanted to send the discussion. Whenever someone says like, okay, we're happy with the design, we can start writing the FIP. So as soon as we're comfortable with the design.
Sure, that makes sense. I think this is how a lot of teams think about it, but it might be helpful if there are open design questions to write the FIP draft first and make those as notes. It will help with discussion, and also it will provide you space as there are diagrams or like contrary design choices as part of technical review and the feedback process. It might be helpful, but also if you wanted to levy a survey or something, again, we could help you.
That makes sense.
Okay, and I would think that it would be good if you could get some feedback from some storage providers.
Can anyone hear me, or are we still speaking? No?
I can hear you.
Oh, good. Okay. Great. Looks like we'll have additional conversations on this going forward. But again, sponsor, let us know if you need additional help in getting this into a FIP, or doing initial survey or analysis to gauge people's interest or feedback. Do we have any other comments or questions? Because this is our last discussion point or agenda for today.
I have one thought about IPC. Okay, the first topic. I think that is very exciting and which is very huge. Okay, so that is also very important for the Filecoin system is because so especially for the the proof of storage. So actually there do not have much more network bandwidth for the contract for smart contract. So there too, and also the subnet or sharding or an IPC will be very important. But okay, I was thinking this one is very huge. Okay, and also is very important. If we think this is the direction, from a community point of view, I would think that it would be very good if we could have a milestone and have different phase to show to the community. And we that may take for example a few years, okay, I guess. I'm not so sure. And when we have this, and we need to for example remove some functionality in the current consensus, or to the sublet as perhaps one some milestones. For example, we could move the Filecoin Plus to a sublet, I guess. Or we even could move the proof of proof of storage, or anything. The basic things to a sublet as one of the milestones. So I mean that if we have that that plan, that will be very helpful for the whole community and also the ecosystem to understand the Filecoin's vision. That's my thought here.
Yeah, we have preliminary milestones and like that we can publish. I think like the roadmap is public, but we should probably come up with a more like visual one, and that's to do for George and I. We probably will have it in the website. We're gonna release a website soon, like explaining IPC and how we're planning to our efforts to scale Filecoin, and we're gonna publish there the milestones, similar to the milestones that FVM has now in their website. Kind of that same approach is the one that we're gonna follow, and we're gonna share it widely with the community. But it's not there yet, so hopefully by the end of the month. But thank you for the feedback. That's really useful.
I agree, Stephen, that what you're raising is a great point. And I think this is a challenge for a lot of teams, because even once they have these resources, there's a lot of information fragmenting. Lucky's primary task right now is to work on launching a public FIPS roadmap also, so that we can coordinate this information and collate it in one place and hopefully share it. So if there's a place that you think this would be most accessible, that would be helpful for us to know too, so that we can draw attention to resources like the website for IC, like FVM roadmaps, like things like this. The challenge again is that they usually exist, they're just really hard to find. So.
Yeah, right. So I also think that this kind of milestone is not from one team. For example, the IPC team and also the FVM team or other teams, they have their own milestone. From a community point of view, they want to actually to do the whole Filecoin as a big picture. We have a direction and the milestone. For example, the next 5 years, something like this. Okay, what's our focus? That might be changed. That might be changed due to some because it's a long-term plan. So but I think it's okay. If we have something, that is better for us, for the whole community to have some, to have more confidence, for the Filecoin, because we have a long-term plan and we are working on this to make it happen, right? Okay.
Thanks. Great points, actually. Yeah, thank you. Are there additional points? I'm just mindful of time. Is there anything else anyone would like to raise or ask or discuss? No? Great. Looks like we are done for today. And I'm looking forward to letting all of us go. It must be brutal for some of us in different time zones as well. So if you have additional thoughts, comments, questions, or anything you'd like us to discuss next month, please do send them over to us, and I'll be happy to put that into our agenda for Core Dev 52. And I will be sharing the recording as well as the meeting materials if anyone would like to read further. Otherwise, see you all next month.
Thanks, Lucky.
Yeah.
Thanks, everyone.